This is the video lesson for acceleration time graphs. The learning target for this lesson is I am learning to read and understand acceleration time graphs. The success criteria for this lesson are: I can tell the important parts of an acceleration time graph. I can describe what direction an object is accelerating based on the object's acceleration time graph. And I can translate a velocity time graph to an acceleration time graph and vice versa. So what's what on an acceleration time graph? So on the y-axis, we have acceleration. On the x-axis, we have time. We read the acceleration on the y-axis. So this acceleration here is 2 meters per second squared. Then we have a change here going from 2 meters per second squared down to -3 meters per second squared here. So we have constant acceleration from 0 seconds to 8 seconds. And then from 10 seconds to 17 seconds, we have another constant acceleration from -3 meters per second squared. And we have a changing acceleration from 8 seconds down to 10 seconds. All right, so let's look at taking a velocity time graph and drawing an acceleration time graph. So here we have a velocity time graph with a negative constant slope. So the velocity is changing, but it's changing at a constant rate. So that would mean that we have a negative acceleration, so a negative constant acceleration. And then we have a 0 slope on the velocity time graph. So that means we have no acceleration. So that means no acceleration. Then we have another negative velocity, or a negative slope on the velocity time graph, which means another negative acceleration. This one's more shallow than the last acceleration. Then we have another no slope on the velocity time graph, which means another 0 acceleration. And then finally, we have a positive slope on the velocity time graph, which means that this velocity is changing, but it's changing in a positive way. So that means we have an acceleration, a positive acceleration, and it's about the same slope as the negative slope here. So we have a positive acceleration. So our acceleration time graph would look something like this. It's pretty sketchy here, but it's going to look something like that. All right, now we got an acceleration time graph, and we're going to draw a velocity time graph that corresponds to that. So actually, I'm going to go ahead and draw some dotted lines here so that we have a cleaner graph. There we go. So now we have some lines to match our graph with. Okay, so we have a constant acceleration that's positive. So that means that we have a changing velocity. It's a positive changing velocity. So that means we have a changing a constant slope that's positive on our velocity time graph. So I'm going to draw a constant slope. Then we have another constant acceleration here that's positive. So we have another constant slope that's a little bit more shallow than the previous one. So now we have a little bit less steep slope. Now we have 0 acceleration. So that means we have a flat line for our velocity here. Then we have a negative acceleration, which has about the same magnitude as this section of acceleration right here. So we have a negative slope that's about the same as this section here. So we have a negative slope right there. So that is what our velocity time graph looks like, more or less, according to this acceleration time graph. All right, everybody, keep asking questions. It's how you learn new things.